So in this unit, previously we just gave a glimpse that why we would use Python and why we are preferring it, why we are using Jupyter notebooks, how do we use it, how do we install it, and some of the theory behind algorithms and maybe some basics of computer systems. So now we will delve into more details regarding the Python, like what are the data types in Python, how do we declare them, how do we use it, how we initialize the variables and constants, and what are the properties of integers and floating point numbers, how do we write arithmetic expressions, process input, display the results, or deal with Python strings. Okay.
Yeah.
So, if you can open your Jupyter notebook, what we can do is we can, at times, I would use them to explain you the intricacies of the variables, constants, and literals, so we can practice it together.
Okay.
So, let's just start. So, the goal of this particular subunit is that how to declare the variables and constants and how to initialize them and understand the properties of different variable types like data types and what are the limitations, how we can use them, and where to avoid using them. Okay, so we will define first the variables, constants, and literals. So you numbers are really important part of any programming language, and it is an important data type in Python as well. So there are these are actually the fundamental building blocks we use to build more complex programs. We can have real numbers, we can have integer numbers, but it's different. If we use them in a different setting, they will result in different outcomes. So we have to be really careful that what we define and how do we define the numbers and how do we use them. Now, numbers can be used in a variety of ways. So if you are designing a program for, let's just say, calculating the area, so in that case, you have to define numbers and what type of numbers you want and what should be the desirable outcome, whether they will be integer numbers, whether there will be real numbers, whether there will be positive numbers or negative numbers. You have to consider them before initializing and before declaring them. Because if you will not initialize it properly, you will not get the desired outcome as you have anticipated.
Yeah.
And we'll see how we can define them with different types of variables. So let's say if you are defining integer, it's 3. Okay. But
Yeah.
if you are defining a floating number, it's 3.0. So Python is as we previously learned that Python is kind of like um, more close to natural language processing. So if you will declare 3.0, it will automatically consider it as a double number. So it will consider it as a floating point number. You do not have to explicitly declare that this number is double. You can, but there is no need to declare it in an explicit manner. So if you are defining 3, it will explicitly consider it as an integer value rather than floating point number. So it's a way to declare the data type. And it's very important that how you describe it, because later on when you will perform any operation, it will result in something that you so it's like if you are adding 3 and 3 and it will result in 6. But if you are only dealing with integers and maybe you can use 5 divided by 2. So it should result in a floating point number which is 2.5. But if you are only dealing with integers, either it will use ceiling or it will use floor to round off that particular number, and it will result in 2 rather than 2.5. So this is one of the distinction between declaring integer and declaring floating point numbers. Then there is variable, and variable is again by name it says that it can be varied. So basically it is something where you store the value. and you can store the value by using name as a reference. So in this case, if you will look in the example, it's x equals to 10 and y equals to 20. So basically, the x and y are variables here, and 10 and 20 are the values that are assigned to those variables. So in this case, the values that are stored in variable x and y are 10 and 20. Then there are constants. So in Python, a constant is a variable whose value should not be changed after assignment. And you can change it, but it's not a good practice to change the constant, because um, it's like if you are defining pi equals to 3.14 and you are changing it for some reasons, so it may not result in it may not provide you the result that you want. Because if you are calculating the area, which is pi r square, and you suddenly change the constant value, then it will not yield the correct results. So in programming, we do not it's not a good practice to basically change the constant, or change the value of the constant. And normally, the convention for declaring the constant is you declare the variable as uppercase letters. So it is known to the programmers that, okay, this is the uppercase letter variable, so it's most probably the constant value that is declared.
mm,
Then there are literals. So previous example, we saw that we have assigned x and y the values of 10 and 20. So x and y were the variables, but the values we store in a variable are called literals. So in that case, 10 and 20 were the literals. And they can be integer, they can be float, they can be positive, they can be negative, they can be string, they can be any other data type that you want. So any value that is stored in a particular variable is referred to as literal.
okay.
Now, hopefully you can answer this question very easily. So I'll leave up to you how you answer this and see if you can get the correct answer. Now, let's delve into the coding example. So basically, if we define a variable data type which is determined by its content, so we can define integer, we can define float, we can define string. But again, beware of changing data types in a variable, because once you change it, it will update it. And sometimes, if you are writing a very long, very extensive code, sometimes changing the variables within the code is not a good coding practice, because it may result in some things, maybe some bugs, or maybe let's say if you are changing the variable to float, but the next input that the variable is used is expecting an integer value, so it might affect your code, or it might affect the outcome that you are getting. It may result in errors, it may result in wrong calculations, it may result in maybe undesirable outcome that you are expecting. And of course, you have to think about initializing a variable before using it. That what type of variable do you want? How do you want to use that particular variable in the code? And before initializing it, you have to follow the convention of defining it, so that not only you would know, but if any other programmer, or if any other developer is looking at your code, it he or she should understand that why you have, what kind of variable you have initialized, what is the data type of that particular variable. So it is quite mm, a good coding practice to actually follow the conventions when initializing a variable. But of course, if you are not following the convention, because everybody not follows it to the T, so you can add a comment. So comments can be added to let the other people know that what type of variable is it, and how you are initializing it. That's what I was saying, that you have to use descriptive names. You have to use a particular convention to initialize the variables,
Mm,
and variables name must start with a letter or the underscore character. It is a good practice to use this. and spaces are not permitted in names. So you will see when there will be some exercises that you will be doing, so you have to consider this, that spaces are not permitted in names. You have to remove spaces. So in order to remove it's like in order to cater the space problem, you can use camel case notation. So camel case notation is something that starts with the lowercase, and in middle, when there is another word to be started, it starts with a capital letter. So you can use these camel case notations to make things easier to read, to make other people easier to read your code. Constants should be in uppercase. Of course, um, it's not compulsory to use uppercase letters for constants, but it's a good practice to use uppercase so that it will be known to other people that are reading your code that you have defined a constant value. And you can use comments in your program to let other people know, or to even remind yourself, because sometimes we write a code, and at that point of time we know that why we are doing this, why we are writing this expression, why we are declaring this variable or initializing the variable. But after a certain time, when we revisit the code, maybe it will not come to our mind. So there, if there is a comment that is highlighting that why this variable was initialized, why this variable was given this particular value, why we define the constant, then it would be easier for you to maybe remember that why you used it in the first place. Or if anybody else is using your code, then it would be easier for them to understand the reason, or the intention behind using those values. So I think you can easily answer this question now, as we have already defined it.
Yep.
And if you want to give feedback based on how you are finding our slides, please click on the link before, and hopefully um, you will get all the points correctly in the questions. So let us maybe use Jupyter Notebook here. I hope I can. Let me prepare new notebook here.
Okay, I'll open a notebook now, and I'll go into just. You just want to me to open the blank notebook, is it?
Can you repeat the question?
You want me to open a blank notebook?
Yeah, blank notebook. So you can practice it with me, or if you want, you can practice it at your own time. So I'll just let you know that what are the variable, how we are defining the variables, and what to do with the Jupyter notebook regarding what we have studied so far.
Okay, just going to open Python 3 now.
So in this case, let's have the Jupyter notebook here. So what we have studied so far is how to initialize the variables, how to declare the
Yep.
constant numbers and all that. So let's say if we have a variable num, and we are defining a number here, which is 20.
Okay.
So by default, it's integer value. So Python
Yep.
understands that this is an integer value and it's not double value. So in
Okay.
this case, let me write a comment as well, that this is a random number initialized to a variable num. So in this case, if anybody else reads this code, they will understand that this is a random number initialized and can be assigned any other number if you want. Okay.
Okay.
Now, now if we want to define the floating point number, what we can do is we can change so let me define something which is, so if you want to print this value, you
Yeah.
can print it. Okay.
Okay.
Now, if we are defining another floating point number, which is 20.0,
Okay.
so it means that Python will understand that this is a floating point number and it should be dealt with uh, different ways. Like if there is a operation which requires division and it should be result in decimal points, so it should return the decimal point number as well. So in this case, if you will see the result, it will be again 20, but and at the back end it will be 20.0. So if let us consider one example to see that whether this is the floating point number or not. So in this case, I'll do is I'll perform division, which is num divided by 3, and I will print div.
Yes.
So
Yeah.
it will automatically be 6.6667.
Yeah.
And let's say if I print div equals to num divided by 5, so it will be 4.0. So it will be automatically turned into floating point number. Now in this case, you will see that I have first defined the div, which is
Mm.
num divided by 3, and it's 6.6667. And
Mm.
then I performed this operation with the same variable name, and then it's updated to 4.0.
Mm.
So this is why it's like you can assign the same variable different values within the same code, but this practice should be avoided because it may result in undesirable outcomes that you want. So this is not a good practice to use the same variable and assigning them different values.
Okay.
Now, this is just the numbers, but you can use different values. For instance, if I use, let's define a string value.
Okay.
Let me define the string value as, so although this is a number which is defined, but I've used quotation marks. So this means that this will be dealt as a string value. Okay, so
Okay.
if I print, it is 20.0, but it's not a number.
All
So
right.
in
Yeah.
this case, if I just use random temporarily temp variable to just use num underscore s plus num underscore f, it will give an error because the num underscore s is a string value and num underscore f is, oh sorry, it's, let me change it. Okay.
Invalid syntax. Yeah. Yeah.
So num underscore f is the floating point number and num underscore s is a string value. So this means that they cannot be used, but I
Yeah.
can use other operations. So if I, let's say I use, so this means that this string will be repeated 2 times.
Okay.
You will see 20.0, 20.0. So this will
Mm-hmm.
be repeated 2 times. So if you perform a certain operations on the string value, it may yield some results, but you cannot perform any mathematical operation on a string value and add the number value. So you have to see that what type of variable you have initialized and what type of value has been initialized. Of course, you can use the Boolean type number, which is true or false. So if you will use true,
Okay.
it will. So this is an initialization of the Boolean value. So you have
Mm.
initialized the Boolean value here. Okay.
Yeah.
So these are some of the examples. And of course, you can print the type of these particular values. Like let's say I have defined num and it will provide you that this is the class integer. So the value
Okay.
which have been defined in the variable num is an integer value. And so you can use the type command. And if you are using num underscore f, this is the floating. So we have defined the same number, which is 20, but the class is different for both of these. And we can also consider finding the type of the string value. So it generates the string class.
Yeah.
And similarly, we can use this for considering
Yeah.
the type of other variables that we have defined. Okay.
Yeah. Very good.
So this is how we define the variables. This is how we maybe initialize the variables. Of course, there are certain operations that can be performed quite easily within different variable types. For instance, if we have, mm, okay, let me just use another. So this is num under num plus. So this is one is the integer value and then another is floating
Mm.
point number. So if you will perform it, you will get the result.
Yes, correct.
Okay. So you can perform these operations, but of course these operations cannot be performed with the string numbers.
No.
Okay. So once this is done, let us move to our next module, which is, so this is also the guided tutorial. You can go through it. So this is a video that has been used to exhibit coding standards and defining literals, values. Now,
Just hang on there. Hang on, Sandra, just for a second. I want to look at mine. I just want to keep a pace with you. Just give me a second. I want to look at that. Uh, okay, go on. Yeah, fine. Yeah, go on.
so now this is code. You can click on the link here, which is fix the errors 2.4 module, and you can practice here what we have learned so far, that how we can fix the following code. So if you will run the following code directly, it will generate an error.
Mm.
Okay, so there is no output, there is nothing. So you need to fix this code. And how would you fix it? So in this case, we can fix the variable names. Of course, you have a different uh, what we say is you will have different values there. Maybe let's say if I use here 9,
Won't work.
or if I use the space here, now you will get the error
Yeah,
that this cannot be done. Okay,
yeah,
so you what you have to do is you have to fix it. You have to fix the values. Now there will be another error, which is table height. So as we suggested, the spaces that needs to be dealt with. So you cannot add spaces in the variable. So what you can do is you can either have underscore, or you can have the camel case
yeah.
notation. So in this case, it will be table height, and it's better to use this, which is, so I think everything is working fine. Maybe there is an assignment problem. So if you will use this instead of this, it may result in error. Okay. So you need to consider the assignment, that whether the assignment is properly attributed or not.
Mm. Okay. Yeah.
And let's say if I have something like this, what would happen is, they are not initialized. So you need to initialize them.
Okay.
Let's say, um, and we have value of text1 equals to 9. So this would work, otherwise this won't work.
Yeah.
And maybe you can initialize the value of car count, and you can initialize the value of my age. Now in this case, you need to understand that if there is any constant value. So if you are defining the constant value, let's say you are defining num underscore table equals to 5. You need 5 tables. So you need to define the constant value as um, the all capital letters. But again, it's not necessary. It's just a good coding practice.
Okay.
Or what you can do is alternatively, you can write that this is a constant value. So in this case, if you will run this code, I think it will run and you can print anything you want. So with the trinket, you can use these. So if I just reset,
Okay.
okay. So this you can practice it on your own. So now I have reset it, and you can uh, maybe correct it or maybe rectify it at your own time.
Okay.
Okay.
All right. Yeah.
Now again, this is another one. If I just reset it, okay. So now I have like these variables, and I need to correct them. So in this case, there is an error, and these errors are related to the naming conventions and the declaration of variables and all that. So if it says that there are 4 errors in the program, so um, you need to rectify these 4 problems. Now, what are these 4 problems? The one is this. So this should be a
Um,
comment,
okay.
not a code. So you need to just add this.
Hash.
Okay. And for the pi value is constant. So you can define it as
Pi.
capital letters.
Privacy.
So it will be um, in the uppercase. This is a constant value. Now, in this case, the 2 errors are rectified. The third error is this variable. Now, this variable has a space.
Space. Yeah. Space.
So
Yeah.
what you can do is you can remove the space, but you have to look at that in the print command, the variable which is given is table area where A is capital. So you can comply it with the same naming convention that has been given in the print command, and then you
Okay.
can use it. But again, we have been defined the radius. So we
Yeah.
need to initialize the value of the radius as well.
Okay.
So we need to define a radius value, let's say 3,
Great. Yeah.
and we can add a comment that we are considering the radius of 3 here. And we have rectified all 4 errors. Now it can run.
Very good.
Okay. So you guys can practice it at your own time, and you can change, you can see the results that whether you are getting the desirable results in this case or not.
Okay.
So you can go through this file as well, variables and constants resource. I've uploaded it. It's just a cheat sheet. It can tell you that if the variable name is this, the variable consists of letters, numbers, and the underscore character. X, of course, in mathematics, we use short variables. And of course, this is legal in Python, but it's not very common. And it should make the programmers and have a hard time to understand that what is the variable doing. So of course you can use them, but the problem is that it is not making any sense. So either there should be context to it, or you can add a comment to let other people understand, or maybe let you understand when you revisit it that this is defined for a certain reason, which
Yeah.
is the comment. Um, so you can use the scan volume, but you need to be cautious because variable names are case sensitive.
Yeah.
So
So that.
if you use lowercase c in can volume, then there will be an error.
Yeah.
And of course, it violates the convention that the variable name should start with a lowercase letter, but there is no any compulsion for you to basically define the variables in a way that the convention provides you a guideline with. You can use any name, but it's up to you. If it will be a good practice to follow the conventions, but again, it's again up to you that how you define it. Variable names cannot start with a number, so this is wrong here. There should be no spaces, so this is wrong here. There are some reserved keywords
Yeah.
in Python, and class
Yeah. I froze mine.